Okay guys, today we're starting a new chapter, chapter 10. We're in lesson 1 today, and this entire chapter is only 4 lessons long. We're going to be talking a little bit about line plots and the data on them and how to analyze them. So today we're going to start with just the chapter and the section that already has the line plots created for us. We just have to answer questions based on the line plots. So our solve and share for today. Several students were asked how many blocks they walk from home to school each day. The results are shown in the line plot below. Miguel walks the shortest distance. Jilla walks the longest distance. How much farther than Miguel does Jilla walk? So we have 2 people that are presented in our problem, Miguel and Jilla. It tells us that Miguel walks the shortest distance. If we look closely at our line plot, we can see that the shortest distance is going to be whatever this first distance is plotted on the shortest end of the number line, smaller than 1. It also tells us that Jilla walks the longest distance. So that must mean the farthest one along the number line must be the distance that Jilla walks. What we don't know yet is what numbers these plots on the line plot represent. That's what we have to figure out. We do know, coming off of a couple of chapters working with fractions, how to divide a whole number into pieces and label those new pieces. So you can see between each of these whole numbers, like between the whole number of 3 and 4, they are divided into 1, 2, 3, 4 sections. That means our wholes are divided into fourths. That would make this first spot here on the number line at 1 whole being equal to 4/4. That means the spot 1 smaller than 4/4, where Miguel's distance is at, would be 3/4. So we can tell just based on this information that Miguel has walked 3/4 of a mile, of a block to get to school. Okay. Now for Jilla, she is the farthest one along. She walks more than 4 miles. Now I could count all of these tick marks along the way and say this one's 5/4, and this one's 6/4, and 7/4, all the way till I get down here to where she was walking. Or I could tell myself, I know that 4 whole blocks is the same as having 16/4, since I know 16 divided by 4 is 4. That would make this next tick mark, that's kind of disappeared under my purple here, 17/4, which would make the tick mark where Jilla walks at 18/4. Now that was a bunch of jumbled up colors right there, but if you need to slow this down or rewind it at any time to see where I'm getting these numbers from, that's the beauty of having it on YouTube. Our question, now that we figured out what these distances are for Miguel and Jilla, is to go back and see how much farther than Miguel does Jilla walk. When I see something that's asking how much more or how much farther, I know that means I'm going to subtract. So I have Jilla's distance, which is 18/4 of a block, and I have Miguel's distance of 3/4 of a block. So in order to figure out how much farther Jilla walks than Miguel, I have to subtract those. 18 minus 3 leaves me with 5/4. Sorry, 15/4. Okay, I have to ask myself how many times that 4 will fit into the 15 so that I can turn this back into a mixed number. If it's into 15 3 whole times, which would be 12, and that leaves me with 3 of those fourths left over. So Jilla walks 15/4 or 3 3/4 blocks farther than Miguel does. Alright, if we will now move on to the second page. The one at the bottom is a question that you can kind of stop and ask yourself and pause and take some time to think about, but it really just wants you to think about how line plots can make seeing information easier. I can easily see how many students walk 3 blocks. I can easily see how many students walk 2 blocks. rather than having all of their distances listed out as numbers, the line plots help me see quickly and easily how many students are walking each distance. So the line plots are a great way to set up data for helping us see a little bit easier rather than having to sift through a bunch of different numbers. Okay. On the next page, this is just giving you the definition of line plot, which you might also see called a dot plot, but it is giving you the definition that they're going to think of in math, and then it gives you another scenario. In science class, Abby and her classmates performed an experiment in which they used different amounts of vinegar. The table below shows how much vinegar each person used. What amount was most often used in the experiment? So this is how most data is collected. It's random. It's organized in the fact that each one has its own spot, but it would be kind of hard for me without sifting through it slowly to see how many times they used 1 cup of vinegar, or how many times people used a half cup of vinegar. I would have to slowly go through and make sure I was paying attention to every single one. A better way to view this data is as a line plot, and they actually already turned it into one for us down here. Now I can easily count up the amount of students that used 1 cup of vinegar, or easily see how many students used 2 cups, or even easily see things like how many students use more than 1 cup, or 1 cup or less of vinegar. Another way for you to look just at how line plots can be helpful for us seeing data. On the next page, we're going to skip over 1, 2, and 3 on the guided practice and just look over at 4 and 5, where kind of the questions on the line plots start. Number 4, students ran for 10 minutes. They ran the following distances in miles. So here is that data set before it's turned into a line plot for us. And they want to know how many distances are recorded in total. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 distances that have been taken. Down at the bottom, you can see they turned those distances they took and they recorded it on a line plot. The question here is which distances occurred most often? Well, that would have been kind of hard for me to tell from the data set up here until they turned it into the line plot. Now I can look and say, okay, I see that 3/4 of a mile looks like it was pretty often. 1 mile was just as often, and 1 1/4 of a mile was also just as often. So I can see the 3 distances that occurred most often were 3/4 of a mile, 1 whole mile, and 1 1/4 of a mile. So again, this is a type of question that's so much easier to answer when we have this view of it in a line plot rather than all these random numbers that we see up top. At this point for 6, 7, and 8, I would like for you to pause the video and get some paper out and answer 6, 7, and 8 on your own. Once you've done that, you can unpause the video and I'll go over it for you. Okay, number 6, how many orders for cheese does the line plot show? Now, it's not asking how much cheese was sold. If they were asking that, I would have to add up all of these fractions. It just wants to know how many orders were placed. Each X represents an order for cheese. So all I have to do to figure out how many orders were placed is count up all the X's on the line plot. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 orders for cheese were placed. On number 7, this is more specific to each fraction. Which amount of cheese was ordered the most often? So again, I'm going to look at those X's and I'm going to see which amount appears to have the most X's over it. And I can easily see that that is 1/2 of a pound. It was ordered 4 times. And so that was the cheese amount that was ordered the most often. And then on the last one here, how many more orders for cheese were for 3/4 of a pound or less than for 1 pound or more? So if you kind of had a question here on this one, that's okay. You probably had the same question in class today, but I wanted to kind of break down this question with some different color on the pen so you can see exactly what we did today to figure this one out in class. The first part of it wants to know how many more. So that right away tells us we're going to be doing some subtracting to find a difference. How many more orders for cheese were for 3/4 of a pound or less, that means all the ones on this side of 3/4, than for 1 pound or more, that means all the ones on this side of 1 pound, including the 1 pound. Just like the 3/4 is going to include that 3/4. So I can see the orders for cheese that were 3/4 of a pound or less was 1, 2, 3, 4, 5, 6, 7, 8, 9. The amount of orders for cheese for 1 pound or more were 1, 2, 3. And that tells us there were 6 more orders for cheese that were 3/4 of a pound or less than there were for 1 pound or more. I wanted to point out on this question also, you need to be careful when answering these types of questions because you might see it written like, how many more orders for cheese were for less than 3/4 of a pound? And in that case, you wouldn't include the 3/4 of a pound in your counting. You would only include the ones less than it. But if it says 3/4 of a pound or less, we know we're including it with that. I'm going to flip the page so that you all can see the next page of this. If you want to pause and work through those, you can as extra work. And then if you get on this on today, which is February 10th, then your quick check will probably be assigned on Pearson if you want to give that a try too. Okay, so this is one you could pause here and work through a couple of these with this data set. Once you're done working up top, you could pause here and work through 12, 13, and 14 on the bottom data set. And again, if you want to finish that quick check, you can. And then now I would take a look at your Lesson 10-1 homework.